can't zoom in recording.
Thank you so much, Swapna, for your wonderful insights and sharing those real life use cases. Thanks a lot. So, thanks, Mr. Chetan, for the next session.
Thank you. Okay. Hello, everyone. Thanks, Swapna. That's been pretty good insight in terms of how the business would work and really what is the justification for you if you need to have an IoT solution, right? So now the context is like assume you have decided you need to build an IoT solution for your business, like you identified a problem. Let's see what goes the next step. This is a technical deep dive. Let's see how much deep we can dig in. Okay, at a high level, this is how I would put the architecture for your IoT solution would look like, right? So you probably have a data collection and control layer at the bottommost, right? Followed by your communication layer, then your data processing layer and application. So let's look at each of these layers in a little bit more detail. What technology exists in these layers and how you can probably start your journey, right? So now let's take the example what Swapna talked about in terms of there was one case wherein you need to do a predictive maintenance of this digger machine in the mining industry, right? So now where you really start with is basically identifying this data collection layer. Okay, so this data collection layer is a place where you really collect the data and then you relate upon somewhere else for the actual processing to happen. Right? So that is the difference with respect to, for example, if you are looking at a standard industry, that is the difference with respect to standard closed loop control system you had earlier versus what we are doing now. Right? Instead of taking a local decision there based on the data you read from a sensor, you may want to actually put the data to somewhere else, right? So that take appropriate action based on more intelligent analysis. How do you get more intelligent analysis? Probably you want to collect data from multiple places, right? So now you're actually maturing from, so what do you call it as Industry 3.0, where like you really had an automated system. From there, to move the data to a centralized location, right? And sort of take a decision looking at multiple data units, right? That's exactly what we're doing here. So the data collection point is where you might have different kind of sensors. Be it, in case of example what Swapna mentioned, like you may want to have a sensor which probably would be detecting the vibrations on these tools, as an example, right? There may be slight variation in the vibration. Now, based on the slight variation in the vibration, you might decide, okay, should I replace this tooth immediately today, or should I replace it next week, or what is the activity that needs to be taken? Apart from that, this layer will also include the control layer. Okay, what is the control layer, right? And another example where we implemented an IoT solution for an agriculture system. So this was basically, they were trying to make a precision agriculture system. The whole idea is they will probably collect the solution looks pretty simple, in terms of you collect the data, send it to a centralized place, you analyze it and give back a response, right? The response could be how much manure you may want to sort of increase to the liquid that's being passed through. Right? Most of this drip irrigation system, you need to probably enable more manure, the manure or fertilizer, which gets into the drip irrigation system based on certain conditions, right? So that's where the control also comes to the part of this layer. The lowest layer, data collection and the actuators, right? So now, depending on what kind of solution which you are looking at, you may want to have one general advice here is we need to make sure both these actuators and controllers are fairly good quality. In fact, I've been working with a smart city solution in Rourkela. They wanted just a simple pollution monitoring system. The carbon monoxide gas sensor, right? There's a sensor which gets show what is the percentage of carbon monoxide in your air, right? There were sensors which cost roughly around 350 rupees to all the way till 12,000 rupees. same sensor, when I say same sensor, in terms of activity that's going to do, same activity, it just measures the carbon monoxide percentage in your air quality. So now, the sensor really comes in very, very wide range in terms of the cost. Obviously, the main thing that happens is in terms of what is the quality of it, like, I mean, how accurate the system is, and what is the mean break time for the system. Like, if you have an actuator, like a relay, right, what if the relay breaks down, when you send a control to switch off the boiler, and the relay breaks down, right, your whole system is gone for a toss, right? So one quick tip here is to make sure in your overall solution budgeting, don't go for sort of, cost is one part of it. Make sure you understand the devices in terms of, what is the accuracy it gives, what is the amount of mean break time it gives, and based on that you decide a right set of equipment here. And next comes your edge communication, right? So now the edge communication component, as I said, like we move from industry 3.0 to 4.0, is where like you need to push the data that is collected on the sensor devices to a centralized location where you can probably start making a better action, right? Now to push the data, you have multiple options. So one easiest option where people do is basically you connect your sensors to a small gateway, right? The gateway device would have for example, a GSM connection, and it just punts the data from your lowest level directly to the cloud, right? That's one common architecture which people talk about, right? In fact, that brings in sort of two architectural solutions for your communication aspect itself. There's something called a 3-tier architecture, a 2-tier architecture. This is a standard architecture which people follow, and as well as given in a few recommendations as well. So you have two mechanisms. So what happens is like, so basically, like, here you actually do the data collection, and you might directly send it to the centralized processing unit using a GSM connection. Pretty straightforward. So other option is you collect the data and then you actually process the data in the edge layer itself, in the place, in the site, on the site where you collect the data, you do the processing, right? So what kind of processing? So very minimal processing. So for example, you may want to optimize the data, you may want to remove the noise in the data. You may not want to send everything, right? If you want to send everything, actually, as I said, like in the agriculture case we were working, they were generating roughly about 120 bytes, right, per sensor per minute. So 120 bytes into 60 minutes into 24 hours into, they had something close to 5,000 sensors, right? Think of how much data we're going to generate there, right? I mean, typically, like based on like how things happen, it might range anywhere between megabytes to gigabytes of data. You may not want to send all of them, right? Then you sort of implement an edge layer. That happens at the site where you collect the data. And you have another advantage of also having an edge layer. So what really happens is, like, now let's assume you take a call that, based on certain conditions, in an industry when they're monitoring the temperature of a boiler, if the temperature goes high, they may want to sort of shut down the heating system, right? And that information can come from the cloud. Okay, look, temperature has gone up and you want to shut down the heating system. And is that a good idea? May not be, right? I mean, what if by the time you really get the information from the cloud, the boiler burns, right? The whole thing bursts, right? So you don't want to do that. So what you might want to do is, this kind of local decisions can be made locally. The critical decisions can be made locally. You may not want to really send the information to the cloud, right? So the question is, what do you really send it to the cloud? Okay, you still send data to the cloud. You analyze the data. You build your models in the cloud. Because building models, which predominantly people talk about, like in terms of you might want to do a lot of analytics there, machine learning. At the end of the day, what it means is you take in data from so many locations, and based on that you say, okay, this is how the temperature should increase, a certain graph. If it's probably increasing in a different way, then things are not okay. This is how the vibration of your teeth in your digger should change. If that can't happen in some way, there's something wrong. That model is what you build in the cloud. Right? So still send the data to the cloud, build the models, understand how the system is in an automated fashion in the cloud, but decisions can be taken locally. Right? So that's where your edge optimization would probably help here, right? Now, this is exactly what happens. If you look at it here, as a part of it, there are really two solutions. One is a simple gateway device connected to the sensor, pumps all the data to the cloud with a single connection. That's predominantly what people start with, right? I want to start my IoT solution. Okay, what do I do? We work with one of the other case, this basically here in India, all across India. It's basically a retail chain. They wanted a simple solution where they say, okay, they want to reduce the power consumption by AC and your lights. So what they wanted is they want to probably, control the lights based on geographic location, right? I mean, if it's northern part of India, it actually becomes dark by around 5:30, while southern part becomes dark by 6:30, and they want to take the geographical location as well as temperature into consideration and decide what they want to control. In that specific case, they didn't have any of the edge computing that needs to be done. They probably pushed all the data to the cloud at one shot, and the cloud was fairly simple there. They only had a simple policy decision, right? No complex analysis. In those cases, probably things work. In other cases, like we have seen cases where people really wanted a 3-tier solution. So where would you install 3-tier solution? As I explained earlier, in places where they probably want to do a lot of local analysis, you may want to take 3-tier solution. Very simple cases, you probably push to 2-tier solution. So next, I actually want to probably cover a little bit on this wireless technology itself in terms of, okay, what are the various technologies that people will have to do as a part of communication, right? So this is basically in terms of the range and the bandwidth you would get. So based on what's your need, you may want to have a local connections, you may want to go large with short range and medium range connections. If you want to send all the data backhaul directly to the cloud, you may want to look for a long range solution. And of course, each solution also comes with appropriate bandwidth, which technology supports what bandwidth, as well as each solution also comes whether it's a proprietary or operator driven or your private thing. For example, things like your GSM, that is 3G, 4G or BSAT, typically operator driven, right? It costs every byte you're sending, you want to pay money for that. Most of these technology, including LoRa, is actually not, they're completely free. But you need to operate it, you need to make sure of it. Similarly on the long range, if you want to send data to the long range, along with LoRa, you also have something called narrowband IoT, which is again service provider driven. You pay for it and you get it. These are the various wireless technology which you could probably use. Then comes your central data processing system, right? In central data processing system, is what you really do is, this is where you analyze your data, right? So you may want to put a very complex system which will develop the model, right? It gets you in terms of, you can put a strong machine learning system which gives a model for how the system should behave, or as how system should not behave, those kind of things, right? You may want to implement a very simple policy-based system also, right? So as I said, we had two examples. In case where they are actually looking at simple controlling of lighting and HVAC systems, AC and heater systems, it was completely policy-driven. Absolutely no data analytics was done. They did data analytics mostly to measure how much savings was incurred, right? So no data analytics to figure out a model there, because it's pretty straightforward, right? In case wherein we work with, we work with one of the smart city solution, wherein they were actually taking up the data from the camera feeds, right? There were cameras installed in various locations. It's still going on right now. They're working on these things. Cameras installed in various locations, and they have a video analytics software which figures out what is the vehicle density, right? Based on the vehicle density of certain roads, they plan to implement the traffic rules in terms of whether this road has to be made one way or not, and those kind of things. And this is actually being done in Electronic City now, right? So we're working through one of the institutions actually developing the solution in the Electronic City. They have a camera, and they have a video analytics system, and also huge storage system. All of them installed in the curb in sort of a locality of roughly around close to around 2 to 2.5 square kilometers. Every 2 to 2.5 square kilometers, they have these devices and a camera across every road. They collect this data, and then they send they do the local analysis, and all the traffic conditions are actually sent to the cloud. In the cloud, they make the model. Okay, the model in terms of what is the traffic density in every road, and how does this change with respect to your vacations? How does it change with respect to summer versus winter, winter versus rainy season? So based on those things, they get a lot of data, and that's what they're actually using to make the decisions on one-way versus two-way and those kind of things. So there you may want to do a pretty complex solution. You may want to have a central data processing unit which does a lot of data modeling. In simple cases, you may not want to do most of it. Okay. There are a lot of solutions available for this. Like you may go for a public cloud system. A public cloud is what many of the people provide, and you can also go for a private cloud, your own cloud as well. It's more in terms of like cost versus your ability to maintain and operate these kind of things, right? I mean, if things are okay, it's always preferable to go with a public cloud system, right? I mean, you don't have a headache of how to manage this. If there is any strong reason like where you want to go, you could actually go with it. These are the various solutions available. Then your application and platform itself, right? So once the data is processed in these centralized units, from there is where you put in your actual business intelligence, right? This is where your command control central will sit in. This is where you based on the model which you identify, what is the control I need to take, right? You put all those information as a part of your applications, including you develop pretty fancy dashboards here, pretty fancy system which can tell you what's happening. You want a system where you want to alert somebody if the truck is going to break down. All these implementation is going to happen in this layer, right? There are a lot of platforms and frameworks really available for this, which does pretty good heavy lifting for you. If you want to set up a simple system wherein you want to do the data processing as well as write your own application, there are pretty good platforms available. Again, I just listed out the platforms in terms of, these are mostly commercial platforms like IBM or Azure IOT or this thing. There are also open source and public domain platforms available, things like Kura and Ka. So they actually provide very similar functionality, but then you might have to do a little bit of lifting over there. You probably take this approach, they probably come with pretty much ready-made solution. So now with this, when we look at all the layers, then what's the other critical piece in your IoT? Yes, like next is basically the security stuff. I may not be talking much about it, but then like yes, security is another very, very critical point which you should probably make sure when you start your embark your journey, think through what should be the security solutions for your business problem which you are solving, right? The reason being, these devices are going to be publicly out there, very easy for people to hack into that in various cases, right? We may not talk too much about it, but that's something which keep in mind. So overall, what is the process, right? I don't know if the fonts are very small. Step one, identify the problem. What is it you want to solve, right? So do you want to worry about your predictive maintenance, or do you want to worry about control? Do you want to worry about policy? Identify the problem, right? What you want to optimize, then decide on the technology. What is the technology you want to use, right? In terms of right sensors and then right compute and storage device and all these things. And subsequently, you start deploy and manage. In fact, deploy and manage also is one of the very, very critical step in your business. Think of this, right? Like I think, as I said, like we worked with one of the solutions where they're supposed to install 500 sensors, right? I mean, installing 500 sensors, that is, onboarding 500 sensors is not an easy task. One is, all these sensors should securely connect to one single place. We need to make sure, right, I mean, they are not they operate pretty much with zero configuration. Because people who are going to install it are not the real technicians who are going to come and install that. Like, you may want to probably entrust it to somebody who's just going to sort of take this device, plug in there, power it on. That's how people might want to do, right? Now, that's why device onboarding becomes very, very complex. Now, how do you make sure which network it connects to, which server it connects to, what policies you want to enable on them? All those things has to be done in a zero-touch way. That becomes other pretty critical part of your solution as well, right? And of course, manage is what you do probably your day-to-day operation in terms of once you have it in place. I mean, you have pretty much automated stuff to manage, but still you need to make sure the devices are in place in terms of devices function, your communication equipment function. You need to monitor and those kind of things. So these are at a high level what I can think of process. This is pretty much where I just want to stop. So if there are, should I want to join in here any questions there? Yeah, okay. Yeah, please.
Hi, I had a question. I know you said security may be touched later in the day, but is a 3-tier architecture a little more secure than 2-tier?
Yes, 3-tier is definitely more secure than 2-tier. So basically, because what happens in case of 3-tier, right? Like I mean, you control what's happening at the edge, right? So you can incorporate your security policies much better in the edge and control what really goes out to the cloud, right? So therefore, like 2-tier architecture, 3-tier architecture is definitely much secure than 2-tier architecture. But only thing is, the 3-tier architecture typically become complex, and that's where like predominantly it's enterprise solutions and live industry solutions is where people use it. Sure.
Where IoT projects fail. There one reason.
I would say a lot of reasons, not one reason. Okay, I'll tell you one. It was pretty interesting actually. I was talking to one of my colleagues. Like I mean, they actually developed a solution for industrial IoT, where they collect data and then they actually developed a command control center. I was talking to him how things are working. I mean, we've been working on IoT. Like how the customer responds. So he said, "Arey yaar, what IoT man? Like at the end of the day, there's this person security guard. When he's going home, when he's switching off all the machines, he switches off network and goes home." Right? Let's take here as an example. Yes, there are a lot of places where things fail. On a serious note, most important factor that actually would fail is basically not able to address the scale. Right? That's what people end up doing. As I said, in case wherein we work with agriculture case, 500 devices deployment, they underestimated pretty much. They thought, just put it's what's a big deal right now. And think of this, you cannot go to every device and configure it. It doesn't work. Right? That is one thing where it failed terribly. And second thing is, people don't put the proper management infrastructure. Right? Basically, again, this agriculture case, because this is where we saw a lot of problem. This was actually implemented near Bangalore here, right? Now, the problem was they were actually experimenting a precision agriculture system. After rains, right? After rains, next day morning, they don't get data from many of the devices, right? The reason being, some of the gateways that were there, actually they had installed the gateway on the ground. Some of them would fall off, and then things doesn't work. Right? And then like if that happens, it's not easy. If you can make a system where it automatically heals by itself, makes a lot of sense. If this breaks, then you need to send a real technician to the Bangalore and ask him to fix. Versus it just happens automatically. This was another very, very big problem we are seeing.
Can we take the questions?
So, in the interest of time, can we take these questions during our networking lunch? I think that